So the problem is to detect a linked list cycle. Now, this problem is fairly easy because you only have to detect it. You don't have to say, which node it is. That would be a little more complicated. But because it's just return a Boolean, just true or false, it's pretty straightforward. Now, there's a few ways to do this, of course. So say you have a linked list that looks like this. Doesn't matter. The values don't matter, so I'm not going to draw those in. Actually, I guess for explaining the not constant space solution, they do matter, so I'll just actually will draw them. But for the actual constant space solution, they don't matter. So like a first approach type of solution would use a hash map, right? Always using hash maps in LeetCode problems. And this is assuming, I guess, in our case, we're going to use the numbers, the values as identifiers. Of course, in a real case, the numbers wouldn't be unique, or might not necessarily be unique. But in this case, just for the example, we'll use them. The idea is to just put the nodes into the hash map, right? And each time on a new node, we'd say, hey, is this guy in the hash map? No. Okay, put him in there. Okay, is this guy in the hash map? No, put him in there. This guy in the hash map? No, put him in there. We'll follow the link, or the cycle. In the hash map? Yes, he is. Okay, boom. Return true, right? That's cool. That's easy. That's straightforward. That would work. But I think, do they have a follow-up or something? Yeah, follow-up. Can you solve it in constant memory? So no hash map is what they're saying. Now the way to do this is with pointers, right? We can have a fast pointer and a slow pointer. We start them both at the head, and all we do is say fast pointer goes by 2. So it says next, so the current node dot next, and then slow moves. And that's one move. They both move. That's one like macro move. Okay, repeat. Next, 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 right? And at this point, at the end of a move, the 2 pointers have ended up being on the same node again, which means there must be a cycle, right? If there's no cycle, you just have nodes, a linked list, that just keeps going. A node that's moving faster will never catch up, right? A node moving faster will never catch up, or will never land on the one that's going slow. The one being going slow will always be, far behind it. The longer they go, the farther distance they'll have between them. But if there's a cycle, they'll eventually end up meeting. So all you need to do is pretty much increment fast twice, right? Increment slow once. At the beginning of this, check same, or the same spot. If they are, return true. Otherwise, keep going until eventually you hit a null, and then return false. Probably the hardest part about this, which is not that hard, but it's still something you got to think about, is how to avoid this getting a null, a null pointer exception. So the way to do that is pretty much before incrementing, you want to check not only is fast.next null, or rather not null, but you also want to check if fast.next is not null. And actually, because you started at head, and this is just an easy way there's 2 ways to do this, but you can also throw in a check there to say if fast.next, if fast is not equal null, and put all this into a while loop, right? And that should take care of all the null checks. And the reason for this one, you could also just slap at the top of the function, just, if head is not null, or rather if not head, then just return false. This just kind of makes it easier to put it in the while loop. It's the same difference. But you need this to check if the next one's null, right? Because if the next, really what it comes down to is if any node is null at any point, you don't have a cycle. But more importantly, you want to make sure, I guess not more important, that's probably the most important thing, but you also want to make sure the next is a null. Because if you only checked the next without checking the next, then you could have something that looks like this, right? So this is null here. So you're here. You're saying, okay, I want to go next, so you can go there, right? Because you go next, and that works. But now you're here, and you're assuming this isn't null, which I guess, honestly, if you have this check, you don't actually need this check. But, you know, it all works. So we have fast, we set the head. If slow, you set the head. And we say while fast is not null, it's not none actually, and fast.next is not none, and fast.next. I think this actually is unnecessary. Let me actually run with this theory. So we'd say fast equals next, fast.next, and slow equals slow.next. We'd say if slow equals fast, return true. Otherwise, we return false. Let me see if this actually works with these null checks. Okay. Okay, it doesn't work. Now, why is that not working? Let me run through that. We got 1, 2. So we set fast to be here, set slow to be here. Say, okay, fast equals .next, which is null, slow equals next. So we do that. We say if slow equals fast, no. If fast is not none, well, it is none in this case. So why don't we just return false? Fast equals fast.next. Why does that not work? I'm not putting true. Because they both, I bet they both equal hit null at some point. So what we're saying is, they're not, okay, no. This guy ends up being null. This guy ends up being 2 though, right? So is fast none? But shouldn't it be? How does that run true though? I don't get that. I mean, I know how to fix it, I just want to understand it now at this point. Well, fast is not none, and fast.next is not none. Okay. Oh. You can't do this check right away because they're both head, which means before modifying it, it's going to check if they're the same, which of course they are because they're both head. So you want to do this first. So now I think maybe I might need that extra check still. Okay, no, you don't need extra check. So yeah, you could either, so there's 2 different ways to do it. You could either have a null head check up here, just return false. And then down here you wouldn't need this check. You could just do .next, and then you could change this one over here to .next. Yeah, so same thing. But because doing it the other way, what you're doing is you're saying, okay, as long as fast is not, what we're pretty much doing is making it next, which might be none, and then checking, hey, wait, before we move on, did we accidentally put it to none? Versus the other option, which is just saying, hey, is the next move a good idea? Is the next move a good idea? Is it possible? If it is, let's do it. So this one's more proactive, saying, hey, let's check if we can do it. If not, let's just return false. We know we can't do it. We're done. The other one is, let's do it, and let's just return false if it ends up not working out. So yeah.